Hi everyone, welcome to a Tess Academy YouTube video. This is part of our GCSE Maths revision lesson series where we will cover topics grade 7 to 9. Today we will run through the sine rule. Remember, if you have any queries, please visit our website at tessonlineschool.com. Also, please suggest any feedback, improvements or suggestions to us through the website. Thank you. The first idea we will discuss is the sine rule. This is one of the most popular formulae that you will have to memorize for your exam, and it is relatively simple to learn. The rule is sine A over A is equal to sine B over B is equal to sine C over C, where the uppercase letters stand for the angles and the lowercase letters stand for each of the side lengths. As you can see in the diagram, the same letter is opposite each other. So for example, uppercase A, the angle is opposite lowercase a as in the side. Additionally, you should be aware of the fact that this formula can be flipped. Right now, the angle is the numerator, but it can be rearranged to make the side length the numerator. So it can also be A over sine A is equal to B over sine B is equal to C over sine C. This is useful in certain scenarios where you are asked to work out an angle or a specific side, which we will look at examples of in the video. Let's look at this first question here. The rule is written for you at the bottom for reference. You should try your best to memorize the formula. The question is, in triangle ABC, AB is equal to 12 centimeters, angle BAC is equal to 80 degrees, and BC is 22 centimeters. Work out the size of angle ABC. The first step is to label the opposite sides to the angles, so the length of 22 centimeters is lowercase a and so on and so forth. The question is asking you to work out angle ABC, which is angle B, but you do have theta as angle C, which you can then use in the formula for your method. After that, you can use your angle rules to work out your third angle, i.e. knowing that angles in a triangle add up to 180 degrees. So we will write the formula as sine C is over C is equal to sine A over A. Substitute in the correct numbers, so sine theta is over 12, which is equal to sine 80 over 22. Since you want to work out the value of theta, make theta the subject as can be seen in the video. Once you plug in the numbers correctly into the calculator, you will get that sine theta comes as 0.5371 and then theta becomes 32.49 to 2 decimal places. After this, you can just subtract from 180 degrees to find your correct angle of ABC. Let's now look at the next question. It would be very helpful if you attempt the question yourself whilst we do it on the screen. It will help you with memorizing the steps of the method and plugging in numbers correctly into the calculator. The question is, in triangle ABC, AB is equal to 22 centimeters, AC is equal to 20 centimeters, and BC is equal to 31 centimeters. We should first label each of the unknown sides with the respective letter, so theta at angle A is opposite side length 31 centimeters. The 21 degree angle is opposite the 20 centimeter length. Use sine A over A is equal to sine C over C and substitute in the correct numbers. Rearrange the equation to make sine theta the subject, which gives you 0.5554 to 4 decimal places, and then rearrange to make theta the subject, which gives you 33.74 to 2 decimal places. Let's look at the next question. It's a bit of a different one because it involves algebra, but it follows the same procedure. The question says, shown below is triangle ABC. AB is equal to 3x, BC is equal to x, and angle BAC is equal to 12 degrees. Angle ACB is an obtuse angle. Find the size of angle ACB. The first step is to label as per usual, so you will find that 3x becomes lowercase c and x is lowercase a. Your formula will be sine C over C is equal to sine A over A. Substitute in the correct values and make sine theta the subject so you can eventually work out the value of theta. This will eventually help you find the value of angle ACB, which is theta. Theta has come to 38.589 degrees, but as you can see in the question, it specifies that theta is an obtuse angle. If you think of a sine graph, you know it is a repeating curve, so imagine that you are moving 90 degrees forwards and backwards onto the forward and backward curves. This is shown by adding and subtracting 90 degrees. Eventually, your obtuse angle will become 141.4, which is your final answer. This next question is very similar where you are working out another obtuse angle. The procedure becomes repetitive now, but starts off with labeling and then figuring out and rearranging the correct formula. The question says, angle ABC is obtuse. Work out the size of angle ABC and give your answer to 3 significant figures. You can have a go at this independently and return back to the video to check your steps and to add any corrections to your method. You will eventually end up with sine x over 20 is equal to sine 35 over 12. Rearrange the formula and work out the value of x by taking the inverse value of sine x. X will be 72.9 degrees, but once again, remember it's an obtuse angle, so subtract x from 180 degrees because of the repetitive nature of the sine graph, and your new x value will be 107 degrees to 3 significant figures. You need to remember to round your answer to 3 significant figures to gain your final mark. This next question is interesting because the diagram is a little bit different to what we have practiced so far. Also, we are now looking at working out a side, so we will have to manipulate the sine formula slightly. The question says, work out the value of x, give your answer to 1 decimal place, and x is a side length. Let's look at triangle 1 first and see what information we can derive from there. It's a right angle triangle, so we can work out the y side using Pythagoras theorem. We then find that y is equal to 12 centimeters, which we can use for triangle 2. Once you redraw triangle 2, you can see it has 2 angles and 2 sides, so we can easily use the sine formula to work out the value of side x. We can work out the third angle just by knowing that angles in a triangle add up to 180 degrees. Because in this question we are working out a side, we can flip the formula and make sides the numerators, so we can easily rearrange. After some rearranging, x is equal to 12 over sine 40, multiplied by sine 75, which gives you 18.0 centimeters to 1 decimal place. This is the final question and the most challenging from what we have practiced so far. You can try this independently yourself to see how much you have absorbed from this video, but remember to return back to the video to check for your corrections. The question is, the diagram shows triangle ABC with D on AC and E on AB. DE is a straight line. AD is equal to 28 meters, AE is equal to 41 meters, DE is equal to 22 meters, and BC is equal to 64 meters. Calculate the length CD. As you can see, we have 2 triangles to work with, and ultimately, we are trying to find out one final length. We label the entirety of AC as y for now for simplicity's sake, but we will return to this at the end of the question. Let's start off with triangle ADE, where we have 3 sides so we can use the cos rule. Just label the sides as shown and insert the values into the formula to work out one angle. In this case, we find that A is equal to 30.376 degrees. Now let's look at the triangle as a whole. Redraw the triangle with the relevant information, and then we can rewrite the formula as y over sine y is equal to x over sine x. We can substitute in the numbers we have to finally give the value of y as 120.4 meters to 1 decimal place. Remember, we took the length as y, so we can subtract the additional 28 meters to find the length of just CD, which gives us 92.4 meters as your final answer. Thank you for watching. Remember, if you would like further support, we offer one-to-one sessions and group sessions for key stages 1, 2, and 3, along with specially formulated 11+ GCSE and A-level lessons. Further information can be accessed on our website at tessonlineschool.com, and if you would like further resources, advice, and feedback, please contact us on the following numbers. Thank you.